Welcome. We're on page 3 of the Chapter 7 exam practice, number 14. We have a random sample of 40 city residents, and it found that 28 believe a streetlight should be installed at a certain intersection. Find the 99% confidence interval estimate for the proportion of all city residents that believe a streetlight should be installed. Okay, so let me first just highlight the parameter we're estimating is a proportion, and that means that the TI 83 or 84 interval we'll use is a 1 proportion Z interval. All right, so it's always good to note what parameter is being estimated. And then the symbols here, so random sample of 40, so lowercase n, our sample size is 40, and 28 would be the number of successes in that sample, and X is used to indicate number of successes. All right, and then we head to our calculator. So our stat, tests, and I'm just going to scroll down here to my 1 proportion Z interval, enter, and then X goes first, so 28, and then N next, 40, and our confidence level 99%, so that will be 0.99, and calculate. Okay, and the directions indicate to round to 3 decimal places. So our confidence interval lower limit will be 0.513, and then less than. And then the population parameter, that symbol is P, and then less than, our upper limit there is 0.887. Okay, so I didn't write a sentence for this one, but I'm still going to speak it. We would be 99% confident that the proportion of all city residents that believe a streetlight should be installed is between, so that would be 51.3% and 88.7%. All right, I'll also just make a note here on the calculator. It gave you the point estimate P hat. So I'm just going to go ahead and do that calculation just to review. So the sample proportion, P hat, we would find by taking X and dividing it by N. So I'll just verify here that that value on the calculator is indeed correct. So if we take 28 and divide that by 40, we will indeed get 0.7. All right, so our point estimate was 70%. Okay, let's go to number 15. A random sample of 12 drivers used an average of 754.2 gallons of gasoline per year. Assume the standard deviation of the population is 33.5 gallons. Find a 90% confidence interval estimate for the mean. I'm just going to highlight that right now. So it's the mean that we'll be estimating. So estimate the mean gallons of gasoline per year for the population of all drivers. All right, we'll round to 1 decimal and assume the variable is normally distributed. So that last part, the variable being normally distributed, is required because we have a small sample size. So a sample size below 30. All right, so let's get our symbols here. So our sample size first, so that would be our lowercase n for 12. And then for that sample, their average, their mean was 754.2. So that's X bar, the sample mean. And then it says, assume that the standard deviation, so when we see standard deviation, we need to ask ourselves, is that for a sample or is that for the population? So it says assume that that standard deviation is for the population. So we have our population standard deviation, and that symbol is our lowercase sigma. All right, so we are estimating an unknown mean, and we have a known population standard deviation. And in that situation, we use a Z interval. So I'm just going to indicate over here, we call that case sigma known. So if the sigma is provided, population standard deviation, that's how we know that we'll use the z interval. So we'll head back to our calculator. So stat tests. And I just scroll again to my z interval. And we want our calculator to be on stats. For statistics, we don't have data. They gave us the standard deviation of the population, so 33.5. The sample mean, X bar, 754.2, and N sample size 12. And confidence level is 90%, so 0.9, and calculate. All right, and we'll round to one decimal place, so lower limit, 738.3. So 738.3 for the lower limit, and then less than sign. And then the parameter being estimated is the true population mean. So in the last example, we were estimating a population proportion. Now we're estimating a population mean. So we want to just check our symbols there. And then our upper limit is 770.1. Okay, again, I don't have the sentence here, but we would say that we are 90% confident that the true mean gallons of gasoline per year for all drivers based on this sample is somewhere between 738.3 gallons and 770.1 gallons. Okay, let's move on here, number 16. To estimate the proportion of a species of rodent that carries a specific viral infection. I'm just going to highlight proportion. We're estimating a proportion. 175 rodents are randomly selected and examined, and it's found that 49 of them are found to be infected. All right, so when we're looking at proportions here, we need to know N, our sample size. So that was 175 rodents. And X, the number of successes. So X, in this case, is 49 of them. All right, so B, the best point estimate of the proportion of all rodents infected with the virus is. So the best point estimate for the true proportion P is the sample proportion P hat. So P hat is called our best point estimate for P. And we'll find that again as X over N. So 49 rodents were infected or carried the viral infection, and N was 175. All right, so 49 divided by 175, and that is 0.28. And I mentioned there, just to put it in a percent form so we can speak it. So my point estimate is that 28% of the rodents carried the virus. All right, sorry, my highlighter is being weird. I just want to get my highlighter back for you guys. But that seems to not be working. I'm gonna try one more time. Okay. So now that we have the point estimate, we'll move on and find the confidence interval estimate. So a 95% confidence interval estimate for the proportion. All right, so when we're dealing with proportions, we know that we'll be using a 1 proportion Z interval. I'll even write that here. So you do a 1 proportion Z interval. And then let's see what we get. So stat tests. And 1 proportion Z interval. All right, X first, 49, and next, 175. Confidence level, 0.95 for this example. And calculate. All right, so my lower limit, rounded to 3 decimal places, is 0.213. And then less than sign. And then P is the population proportion we're estimating, less than sign, and then upper limit would be 3, 4, 7. Okay, so I'm continuing to write the intervals in the form lower limit and then the parameter. So choosing the correct symbol for the parameter and then the upper limit. And then we will write a sentence here and express those as percents. So based on a sample of, that was 175 rodents, we estimate with 95% confidence that we're estimating a proportion of all rodents infected with the virus is between, so that would be as a percent 21.3%, and upper limit 34.7%. Okay, one more on this page. So number 17. A random sample of 9 adults were asked to perform a given task. The time and seconds it took each of them to complete the task follow. Assume the variable is normally distributed. So that statement again is needed because our sample size is small, under 30. And let's find A, the best point estimate of the population mean. All right, so if we want to estimate the population mean, which is mu, our best point estimate is the sample mean x bar. So what we'll do here is enter the data into our calculator. So if you want to pause for a moment and get that data in L1, I believe I've done that already. So stat edit. So we want the data in the calculator. And then just for practice here, before I go to the confidence interval, I'm just going to use 1var stats to find x bar. So I'm going to go stat, calculate 1var stats. And my data is in L1, so I can just hit enter and we'll round to 1 decimal place. So that would be 37.8. So 37.8 seconds would be my best point estimate. All right, then we go on and construct the confidence interval estimate. All right, so we just need to remember that when we are estimating a mean, you have to choose either a t interval or a z interval. So the question becomes, are you going to go with t or z? All right, it's all based on whether or not they gave you the population standard deviation sigma. So when we read that question, they don't mention assuming a population standard deviation is a value in any way. So if we don't see population standard deviation, we know that we're going to go with a t interval. So we would say it's a t interval because population standard deviation is unknown. So sigma is unknown. So we're going to know the sample standard deviation because we have the data, and I'll show you that value in a second. But the key is t if they don't give you sigma. All right, so let's go to our t interval. So stat tests, and then t interval. And then in this case, they gave me the data. So I'm going to select input data. And you want to make sure the list says L1, assuming you put your data also in L1. Frequency stays 1, confidence level 0.95, and calculate. All right, and we're going to round to 1 decimal place. So lower limit 32.2, and then less than sign. And mu is the parameter we're estimating, population mean, and then the upper limit over there will be 43.3. Okay, so let's summarize here. So based on a sample of 9 adults, we estimate with 95% confidence that the true mean is the parameter we're estimating. So the true mean time it takes for all adults to perform this task. So based on this sample, we believe that for all adults, the time is somewhere between 32.2, and our units are going to be seconds. I'll just put the seconds over here. So 32.2 and 43.3 seconds. All right, so before I end this problem, I just want to go back to standard deviation. So S there on your calculator, that is the sample standard deviation. So if you have data, you'll always know the sample standard deviation. It's the fact that they don't give us population standard deviation that leads you to choosing a t interval. All right, and that wraps up